Okay, now we have got our bronze layer with all of our daily pricing data. Okay, when we are building our silver layer in the data factory code, what we did was we have merged this daily pricing data with one of the geolocation data and the weather data. There are two data that we ingested into the branch layer from the APIs, and we have merged them together in the gold layer in the data lake. In the silver layer, we have transformed our API data into the flattened format. Then when building the gold layer, we have integrated all of the daily pricing data and this population data and the weather data together and created the final view on that one. So this API data is existing in the internet. We need to ingest that in the branch layer. In this time, I'm not going to copy from existing data lake storage account. I would like to write the code in the Databricks to read the data from the original API and how we can format the data and ingest in the branch layer. So probably we'll create the new workspace. So now, do we need only one notebook or multiple notebook? Okay, that question also will come. We need one notebook for one source to one target. Okay, if you are reading the previous case, we are reading the data from data lake storage account and trying to ingest into the another container under the branch layer. That one specific operation. Don't try to mingle other operations with that notebook. Okay, we keep it very simple. Each operation create the different notebook. Now we are going to ingest the data from API into the branch layer. So better to create the new notebook for that one. So first we are going to ingest the geolocation data. Okay, so again I'm saying that probably the numbering system, it's okay actually, 0 1, this is again new ingest for branch layer with the, we call it as geocoding data in the ADF. Okay, now our source data is existing in the website. We are using this API to call the actual, sorry, completely, I need to copy only the URL. If I pass this URL, I am getting the data in the JSON format. This is the API results return data. So I need to get this data inside the Databricks, and then I need to convert that into the data frame. Then I need to write it that into the branch layer in our new data lake storage account. Under the data lake house, under the branch layer, I'm going to create the new folder called geocoding, and under that, that data need to be ingested in it. All of this code we need to do it via Databricks. Now this data is external to this Azure. Okay, this specific data that we are talking about at the moment, this API is not existing inside the Azure. Previously our landing container is existing inside the Azure. So we went over there and we identified the access keys of that data lake storage account, and we used that in the code to read the data from the data lake storage account. But now this data is not existing inside the Azure, it's existing in the web. So you need to use some of the Python libraries available to read the data from the web. There are set of libraries will come by default in the Databricks cluster. The additional libraries that you need to use, you need to import that libraries inside your code. For example, we are going to use the HTTPS request library of the Python to make a request to this web page and read this data. So this request request package don't come by default in this Python environment. So we are going to import that specific additional library here. Sorry, the request is not the actual library, it's called requests, okay, to make them. So how we are going to use this one, we are going to shortly see it. So this request library is used to make a HTTPS request to any of the URL that you would like to read the data. This is our URL. So as a standard practice, all of the package installation, additional Python library installation, keep it in one cell, and all of the variable declarations you will do it in the another cell. When reading the data from that specific source, put it in the another cell. Don't try to mix it up everything together, because if you want to run only importing these libraries again subsequently for any of the code that we are using it here, we can come here and we can add that additional library and we can run only this cell. So my source URL, source geo coding URL is existing in this path. Okay, this is where my source URL is existing. So the standard practice, always store that in the Python variable. I am storing that in the Python variable. Now I'm going to use this request library, okay, the request library will take URL as a parameter, and I'm going to make a request from here. So I'm saying that if I type request dot, there are set of methods are here. I'm going to get the value from this URL. As soon as you type the proper function, it is asking what is the URL for that one. My URL is existing in this variable. So we try to display this value so that you know what it is coming from this one. Okay, dot, I'm requesting this URL. I know that this URL will return the data in the JSON format. So I'm specifying bring the data in the JSON format, so that if I make this request, if I run this command, it's going to physically make the request to this URL. Your request means how we are opening this URL. Okay, when you are typing the URL, when you are entering, that means you are requesting that URL to respond the values. The same thing we are simulating it here. That's all we are trying to do it here. Okay, so now if I run it, probably it may error it out. It is having, okay, it's properly returning the data because I have given the JSON format. The same value that you are seeing in this web page, it is coming here. Okay, via the program we are trying to open the specific URL and get the output of that URL into here. As I said, this is just making it. Now it is not stored anywhere. Okay, output of this request, if you store it in one of the variable, for example source geo coding data equal to, so now everything is stored inside this variable, so that we subsequently use this variable to store this data into our data lake storage account. If I print this source geocoding data, the same value coming in this website output is coming into this variable. That's all we are doing it here. Okay, so now this is existing in the JSON format. Now we need to convert this. So far there is no Spark code is involved at all. Okay, it's only the Python code, Python request, the standard HTTPS URL. Python made the request to this URL and we stored in the Python variable. Okay, so we need to convert this Python variable into the Spark specific variable, literally Spark data frame. Then only we can able to write it into the Spark. We use the Spark and we can able to write it into the data lake storage account. So this is in the Python variable. There are set of codes that I am going to do it here. This is basically formatting any of the JSON data to convert it into the Spark data frame. Okay, any of the JSON data you can follow the same format to convert that into the data frame. Okay, for specifically for JSON. Okay, so this is the output of this web page. I am going to convert this into the JSON source geo coding data. Still I am using the Python only. I am not using any of the Spark code yet. Okay, JSON, that is the additional library I needed. I am going to dump entire data coming from this website output. It is displaying here in the JSON format, but it's not actually a JSON data yet actually, because output of this web page is coming as JSON format. That's why when you are printing it, it is displaying in the JSON format. If I give any other URL, for example, bbc.co.uk, this request will bring back this entire data in the HTTP format. I need to convert this into the JSON format because we know that the output is in JSON format. If I convert that into the JSON format and write it, subsequently I can able to use this data. That's all I'm trying to use. Okay, I'm dumping all of the web page URL output into the JSON format first. Actually, it is going to give the error saying that JSON is not defined. JSON is one of the Python library that won't come by default. So all we need to do is that import JSON. And you can run this cell alone. Now the JSON library is available. This is the step we need to convert the source data into the JSON data. Okay. Now we converted into the JSON data. This is the general rule. Okay. This is the general rule. If you want to convert any external data, okay. When I meant external data, it is not in the Spark data frame. Any external data you want to convert into the Spark data frame, first you need to convert that into the list or array. Okay, if it is in the array format, then only you can able to convert that into the data frame. If you have noticed previously, probably I will open it. Whenever we are running the data frame, only displaying the data frame structure, it is using the array data type. That is the nature of the ingest bronze daily pricing. Whenever you are creating only the data frame, probably I can run any one of the command. Those data frame write option, Spark read option. Yeah, if you look at it here, because I have assigned this into the variable, I just remove this one. I run it without assigning the variable. Whenever it creates the data frame, it will give the format as array or list. Okay, in Python it's basically opening square brackets and the opening close brackets. Actually, if you look at it, data frame starting with, it is everything inside this array. This is the opening square bracket, and this is the one I'm talking about it. So I will put that back. Source df, right? Source df equal to, in this code, if you type it, you can't able to control Z it. Okay, it automatically save it. It should be fine, and I can come back to this one and I edit that one. So now we converted our external data into the JSON data, but I would like to convert this into the array data before I am loading this into the data frame. Why we are loading into the data frame? Without we are loading into the Spark data frame, we won't be able to write it into our data lake storage account. Still, you can use the Python to write it back into the data lake storage account. In that case, we are not using the Spark cluster. Our ultimate aim is we are processing the huge data, so we need the Spark cluster. So this is all the steps. Any external data coming inside the Databricks, you need to do this step. Okay. So JSON source data, it's a list. Okay, I'm just creating one variable with I'm just creating the Python variable as a array data type, and on top of this variable I'm going to dump all of my source data that is existing in the append my original source data. Okay, I will come back again. I will tell you. Okay, there are multi-step process, and this is needed for processing any of the external source data. Okay, now if I print this JSON source data list, it will print it in the array format. Okay, previously when just I print the only print the JSON format, there won't be square bracket in the beginning. Okay, if you look at it, it's starting with opening braces, but if you look at it here, it's converted into the array variable. So you get your external data and you change your external data into the actual original source format. In this case, it's in the JSON format. That's why I changed it into the JSON format. Then you need to store your source data into the array. Whatever the values you are getting it, you need to store it in the array, because without making it into the array, we can't able to convert that into the data frame. Okay, so read your source data, and depending on the output of your external data, convert that into the specific format that it supports it. If our external data is coming in the CSV format, instead of it storing in the JSON, I probably will convert it into the CSV. But still, this step is still required. Okay, after converting into the CSV, you need to store that inside the array variable. There is only one more step. Okay, there are too many steps actually. I'll remove this print to make it code little followable. Yeah, the print one. I want to see the difference between multiple things. Okay, so now we converted into the array format. Now I can pass this value into my Spark code. Okay, so the Spark code has got two steps. Okay, so far we have used only the Spark keyword. There is another thing called Spark context. Okay, Spark and the another one is called SC. SC is called the Spark context. Spark is little high level abstraction variable. That means if the source data existing in the data lake storage account, you straight away use the Spark command to read it, Spark command to write it. But if you want to go one level lower than that Spark, that is called the Spark context. It's got the default variable called SC. Okay, we used to do it very in the earlier days of the Spark. There is no keyword called Spark. We always use the Spark context SC. Okay, there is a concept called parallelize. What it is meant is, this data is existing in the array, but I am going to use inside my Spark. When using inside the Spark, always I distribute the data into the multiple worker nodes. So I want to parallelize this source data. So that's all. This is the one of the keyword. There are so many steps to convert external data into the Spark data frame. So this step, okay, there is here one more keyword. We will be learning it here. It's called source geocoding RDD. Okay, probably you might be heard about it. This is the one level lower on the data frame. Data frame itself is the one layer on top of the file. The RDD is resilient distributed data set. If you remember in the Hadoop architecture, when I was talking about it, we were talking about it blocks. Actually, the file will be split it into the blocks. In the Spark, the files will be split it into the RDDs. Okay, and that day Balaji asked the question, you follow the map reduce process. I said yes. But instead of blocks, the Spark splits the source data into RDDs. It's called resilient distributed data sets. That is the one level lower the data frame, okay, very lower level. If the data is available inside the Azure, we don't need to go this level to convert our source data, but all of the external data you need to convert into resilient distributed data set. Now literally after this is going to be the Spark variable, okay. Hereafter we can use the Spark keyword to read the actual data or actual write the data, okay. So probably now I will use the keyword. Again I will explain to you, okay. This is so many steps actually. Source geo coding data frame. Now only the data frame is coming. So this is why when dealing with external data, we need to do too many conversions before ingesting into the Azure cloud. But in the data factory, this is and all internally handled. It's not using the Spark code, but it has got the internal libraries to read it and write it into the Azure very straight away. But in Databricks, ingestion is still possible, but you need to do multi-step process. So if I say Spark read my source data is existing in the JSON format. Now if I pass my source geocoding RDD and now display df, it will display. Now only actually from these two steps only started to using the Spark. Until then we try to convert all of the source data into the first we made web request using the Python library request, then we converted the written data into the JSON, then we stored that JSON into the array variable because Spark needs the data to be inside the array. Then we converted this array into the RDD, that is the resilient distributed data set. This is the one step below data frame. It's the lowest level, how the Spark will split the data into multiple nodes when running in the cluster. Then we started to use the normal Spark read, okay. Now we can come to the previous Spark read level, okay. So now you want to write this into the data lake storage account. You can straight away write in the any format that you are need to, okay. So for example, I have read my source data now. It is existing here. I'm going to write this into the data lake storage account under the container data lake house under the branch layer, and I'm going to store that as a geocoding data. I think we can use the previous assignments. So branch daily pricing folder, I will copy this variable so that we can straight away use it, okay. So this is not the daily pricing, it's the geocoding folder, right, because this is the different data. Under the data lakehouse, under the branch layer, I'm going to say that geo underscore coding. Now we have set this folder. Our source data frame is existing here. I'm going to write this time using the JSON format. I'm not going to use the barcode format because any external data that you are bringing into the Azure cloud in data analytical project, first layer, it would be better to store it in the same format that you are reading it. For some reason, some of the records are missing or some of the records not come through from the source. It would be little difficult to debug it if we are keeping it in the different file format, okay. So branch geo coding folder. Now if I write this into that one, hopefully it should work, or it will give me the error saying that detected for value, because if you note it down, each time you need to set the storage account key. Otherwise, this when you are setting this Spark config to connect to the data lake storage account, it is not applicable at the cluster, it's applicable at the notebook. When I started this notebook, I didn't set the permission for reading or writing the data from my data lake storage account. So I need to rerun this code. I will be telling you how to write this how to configure this one permanently. I thought it will take a little time actually to teach you all of that. The security settings is the little lengthy process. You need to use the key vault and additional components. I would like to get you into the coding very quickly. That's why I'm just giving this hard-coded paths here. Sorry, I need to copy my key. For each notebook you need to set it once. That's it actually. If you set it, it will be okay. Even you can delete it, it won't work. Now it's set it actually. Now if you run this code, the previous error is related to this notebook. It couldn't able to access this data lake storage account. Now it has written my JSON files into the data lake storage account. If you come here, if you go to the containers, in the new container that we created it, if you go to the branch, it created the new folder here and it's read the data and it has written the data into our branch layer. This is the same data that we have written in the ADF also using the same request. So we did a couple of steps. I can repeat it again. Okay. This is coming from the website API. So we have used additional Python library called request. So the request will get the data in the HTTP format. In fact, when made the request, it is coming in the HTTP format, and we converted that HTTP into the JSON format. Then we converted the JSON data into the array of JSON values, because to convert that into the Spark data frame that is required. As because of this external data, we couldn't able to use the Spark directly. We have used the resilient distributed data set using the Spark context. Then we used the normal Spark to read the data, and we have wrote that data into our data lakehouse container that we created it. So this is to bringing the external data into the Spark data frame and writing inside the Azure. Always need these steps actually. The Spark example, this source geocoding URL. Okay, this is where my source data is there. This is also one of the website path. If you think that why we can't write spark dot read dot, the data written there is JSON. Okay, so if I give the URL directly here, it will error it out because this Spark API is not able to read the data directly from the URL. You need to use the Python library to read the data and convert that into the different format. Then you will pass that into the Spark data frame. Then only Spark can able to read or process that data that we need to aware of it. If the code is existing inside the Azure, for example in the data lakehouse or the SQL table, we don't need these conversions. Spark can able to directly read or write in the data lakehouse because those libraries are developed in such a way. Okay, and first of all, this code is not in the JSON format. If you made the request to this URL, it's coming in the HTTP format. Can I give you a pause here? Is it something followable? In roughly, you read your data from the external, wherever it is, it can be in the URL. We are going to see it from our SQL Server database as well, how to read it. And you need to convert that into the Spark RDD, okay, the resilient distributed data set. Probably there will be one question as well, what is RDD? RDD is the lowest component that Spark cluster will split the data to distribute the data into multiple nodes to process the data. And the data frame is one layer on top of that RDD. The data frame, working with the data frame will make our life simpler actually. Where the same code that we are writing on using the Spark, you can able to write it using SC as well, but you need to use very low level Python libraries to process the data. That's why they created the Spark abstraction layer, Spark data frame abstraction layer to simplify the code. So we need to know what is RDD. Nobody is writing at the moment at the RDD level of coding. Only when bringing the external data into the Spark, we are using it. So in the same way, okay, I will give the part of this code. In the same way, we are getting the data from weather data from the external API as well. The same steps you need to follow exactly. Only the URL will be different. Okay, so you practice that one. For the next URL, I will give this code set. You import this code set. Even you can run this one in your Databricks cluster and create the copy of this one. Okay, probably you can even learn that one here. Yeah, you can able to clone this one. Okay, that is the option I want to teach to you. If you clone this one, it will create the copy of the same code again. You need both the codes for your testing. So it's going to be the weather data, and all you need to do is that you need to change this URL. Okay, and also your variable names. It's pointing to the geocoding. It's a standard practice to if you look at it now, actually how easy to this is the advantage in the using the coding practices. Okay, so I'm going to change this code into this. I'm just going to change this URL only. The remaining code exactly will work fine. Only the folder names and the variable names I need to change it. So I change it into the source weather URL. So wherever I am using source geocoding URL, source weather URL, then all of these variables you need to change it. Okay, probably I'll stop until here. The remaining code, just changing the variable name, it will perfectly will work fine. Okay, that is the advantage of using the programming. The remaining things you change it, you can able to ingest the weather data also into the branch layer.